Hi everyone, so I'm going to be doing a revision lecture for practical test 1 today, and what I'm hoping is that everyone can see the screen, but because it's in front of me I hope it's being recorded so you can see it as well. This is really just a test. I'm trying to do this recording from home to see how it goes, and hopefully it all goes smoothly. So let's get started. So what I want to do in this example is we're going to create a Visual Studio project, and then we're going to create the project in order to create a calculator that converts binary numbers into decimal numbers. So just for a bit of a refresher, I've put a series of binary numbers here in a notepad window. So these are all the binary numbers consisting of 4 bits. So we can see we've got 0, 0, 0, 0, which is decimal 0. We've got 0, 0, 0, 1, which is decimal 1, and so on, up to 4 ones, which correspond to 15. So just in case you've forgotten exactly how you convert binary to decimal, let's do a quick example. I'll pick, say, this one here. And the way we do it is we need to add the powers of 2. So this is going to be 2 times 2 to the 0. Now I'm using that as an exponent because I can't on Notepad put a little exponentiated symbol that sits just above the 2, so you have to read this as 2 to the power of 0. This one is going to be 2 to the power of 1, this one is going to be 2 to the power of 2, and this one is going to be 2 to the power of 3, and since 0 times anything is 0, we can delete these. They just all become 0. And then we can work out what that is. So 2 to the power of 2 is 4. 2 to the power of 1 is 2. And that, of course, is 6. Okay, and I've got 6 up in the table here. So the aim is to write a program where someone can type in 4 binary digits and then get the decimal result out. So let's create a new project, and I'm going to search for the Windows Form app, which is here. I'll just give it a name, binary, well, let's call it binary to decimal. That's a good name. So I'm just making this up as I go. I haven't practiced this project or anything before. Okay, so it's not liking that name. Let's just save it somewhere else. Desktop sounds good. Great. No, it doesn't like that either. That's interesting. Let's try that one more time. No, it doesn't work. So let's put it onto C drive in Windows temp. I think there's a temp file, some directory. Yeah, I'm not going to be allowed to do that. So that's interesting. Looks like I can't actually save it anywhere. Okay, well, let's try the downloads folder. Okay. So for some reason I'm allowed to create a project in the downloads folder, but I have some permissions error in all the other places where I wanted to save it. So I apologize for that little glitch. That's a shame, but we managed to work our way around it. Okay, so we're back to our form. I'm just going to click start to make sure the project is created properly. That's a good way to start off, and yet we get a blank form. So I will now clear that, and I'm going to drag across some controls. So what we're going to do is a 4-digit, we're going to have 4 binary digits that the user enters in 4 different text boxes. They're going to click convert which will be a button, and then the result will be displayed. So I'm going to go with the text boxes first. So we'll put that there. There's the first text box, and we'll have a label above it. So I'm going to put the labels above the controls. I'm going to increase the font size to make it a bit more readable if you've got a high resolution screen. Let's give it a modern font. Okay. And then I'm going to line up the controls. So let's unselect and move that there. And I'm going to copy these 4 times for each of the 4 digits. So let's go Control C to copy and Control V to paste. Okay. And that's going to be our 4 binary digits. So I will edit the labels. So I'm just going to call this digit 0. Now that's now I've selected both of these, so I'm just going to call that one digit 0. That's going to be digit 1. That's going to be digit 3. And that's going to be digit 4. And I'm going to select all of these. And I'm going to set the default value there just to 0 for everything. Okay, so by default all of these are 0. I might center them. So let's go and find the text alignment. We'll center the digits there. Okay, so that's the 4 digits that I'm going to be reading in. Let's name the controls. So far they're just called text box 4, 3 and so on. So I'll call this text box digit 0. This one's going to be text box digit 1. This one's going to be text box digit 2. And this one's going to be text box digit 3. Okay. So far so good. Let's move the labels along so they line up in the center of the controls a bit better. We'll throw on a button. Okay, so we're going to use this to convert the binary number into something. So I'll call that button convert. And we'll go down to text and say, I'll call that convert like this. So the ampersand in front of the C means I can just press that button by pressing Alt C. Okay, and we'll just give that a nice big font as well. Where is that? Yeah, and we'll go up to some big size. Doesn't have to be exactly the same. And the last little bit is somewhere to put the output. So I'm going to again, we're just going to use a well, we could use a label. Yeah, we've got 2 choices for the output: a label or a text box. I've got a rich text box here. That's interesting. Let's go for a text box, and just to make it do something a bit different, we'll make it a multi-line text box. So if we go down to the one of the controls properties, we can see that there's a setting called multi-line, which by default is false. So that means a text box only has 1 line by default. But if I make it true, you can then see that I can now resize the text box and make it much larger. Okay, so let's what's next? Let's make it read only because it's going to be for the output. That changes its background color, and we'll size the window to so it nicely fits all the controls, and that's the user interface designed. So let's press start and see what happens. Okay, so it looks like we've got the text boxes. We can press convert. We can't edit the text box, so I'm trying to type on the text box, but nothing's happening. I can enter things into here. And of course, they might not be binary digits, but yeah, it works. Okay. Let's now do one more thing. I forgot to change the font on the multi-line text box. So we'll go up to font. Excuse me. I wish that the recorder would automatically delete coughs. That would be great. Okay, so that means the output. Yeah, I've just changed the output font of the text box to something fairly large so that we can all see it. Alright, so let's now do some programming. So this entire program is going to happen when we click the convert button. So I'm going to double click convert, and that will bring up the code. And of course we can always get back to the design view by clicking on this tab. So we're over here in the code, and now we have to think about what we're going to do. Okay, so basically for any program you need to have 1, some code to get the input, 2, some code to do some processing, and 3, some code to do the output. So we can immediately write some comments in this empty block of code to specify where those parts are going to be. So here's a comment saying get the input, and what's the input? The input's going to be 4 binary digits. Okay, let's do the processing. It's going to be converting the binary number into decimal, and the output is going to be displaying the result. Okay, and I can be a bit more consistent if I want to. I can make my comments look a bit more professional by using a consistent capitalization style and commenting method. Okay, but there so my program is going to exist inside this button convert event, and I'm using comments to divide it up into 3 parts. Okay, input. Well, we have to get the 4 binary digits somehow. Okay, if we look back at the design, what we see is that these are text boxes. We already know that because we set them up. So anything that gets typed into here is going to be text. So that's a problem to start with, because in order to convert the binary number to decimal, we need to have those digits as numbers, not text. So let's think about how we convert the contents of these text boxes to strings, or to numbers, sorry. So we have done that before quite a lot using the parse method. So let's set that. Let's do that. So I'm going to create 4 integers. Okay, and these are going to store the 4 binary digits as integers. Okay, so I'll call it digit, oops, spell it right, so digit 3. Now I'm going to give them a default value of 0. This just means that if our parsing later on fails, then the whole program will work, but it'll assume that the inputs was 0. Okay, so I'm declaring 4 variables, and I'm going to set them all to have a default value of 0. Okay, so there we are. That's setting up the variables. Now this is technically not part of the input, so I could in fact put that at the beginning as a separate code block and then add a comment saying declare variables. Okay, so maybe we'll do that. So every time there's a variable, we'll set it up we'll declare them up in this block here, which is separate from the input, processing, and output. So I've made a bit of a boo-boo here. That should be digit 0. Okay, so now let's use parse to get the variables. So we'll start with digit 3. So digit 3 equals int.parse. So this is how we do the parsing. And what are we going to parse? Well, we need to find the text box. So the text box is called text box digit 3, which is down here. So I can just double click that. And we want to get into the text property. And don't forget the semicolon at the end. So there we've got the contents of text box 3 and put it into digit 3. Okay. Let's now duplicate this line and change it for each of the 4 boxes. So far so good. Make sure we change the variable names. Okay. Now at this point we have, if the user has typed in 4 valid numbers, then the parsing should work, and these variables here will have their values set. So just to make sure that these values actually are being set properly, I'm just going to type something into the output block of our program, or part of our program. And so the idea here is this will just be a bit of a sanity check to make sure that what is in the variables digit 0, 1, 2, and 3 is actually what the user has typed in. Okay, so to put output into a text box, I'm going to need a string. So I'm going to need to create a string. Now again, this is a variable, so I could define it down here if I wanted to, but since I've already created a declare variables block up here, I may as well move that up to the top. And then down here I can then create, I can basically set, well, I need to do 2 things. I need to put something in the output string, and I need to then set it in the text box. Okay, so let's do the first thing. So we'll go output equals output plus. Now how do we convert a integer to a string? We use .toString. Okay, so output gets output plus digit 3 to string. Let's then put a space after that. And so that should tell us what the contents of digit 3 is. Let's continue doing that for the remaining digits. So we have 2, and we have 1, and we have 0. And the last thing we need to do is set the actual text box itself to that output string. So again, if I type text box and output, and I don't think I've actually named that output text box, which is a problem. So I'm going to have to go back to here, click on that, and I have to give it a name. So I'm going to call it text box output. Okay, and we go back to here, we say text box output dot text equals output. Okay, so now we've got some input and we've got some output. We don't currently do any processing, so let's now run the program and test it. So if I just use the default values and click convert, then I get 0, 0, 0, 0. Let's put in some binary digits, make them all 1s, click convert. Yes, I get 4 1s. Let's make a bit of a different one and click convert. Yep, so I get 4 digits, 1, 0, 0, 1. Let's press something else that's wrong into one of those text boxes and click convert, and we get an error because the number that I typed in, of course, wasn't a digit, it wasn't an integer, and I tried to parse that, it was a letter. Okay, so let's close that, and we have to fix that mistake. Now to fix that, I'm going to have to stop the program running. It's actually still running, it's in debug mode, and you can see where the error occurred. Okay, that's makes sense since text box digit 3.txt had a letter in it. So I'm going to click stop, and we're going to use our friend try and catch. So try and then catch. And message box dot show please enter valid binary digits in the text boxes. Well, I could say binary digits, they're also called bits, so let's just call it bits. Okay, now what's going to happen if there's an error? Okay, so if there's an error, and when what the user's typed, what's going to happen is this code here would have already run. So these four variables will have value 0. Then an attempt would have been made to run this code, but there would have been an error. So it would have then jumped down to here, and then the program will continue onwards, okay, because it doesn't crash. That's the whole point of the try and catch. So the result is that you'll get some kind of output, but we're not exactly sure what it's going to be. So let's just run that and see what happens. So 0000 is a valid input. I'll hit convert. Program works fine. Let's just add a 1 there. Convert. That works fine. Let's now add an incorrect input there, H. Click convert. I get the message box. Please enter valid bits in the text boxes, and click OK. But then interestingly, the program outputs 0100. So you may wonder why that happens. Well, the reason is, if we go back to the program, this has happened successfully. This has happened successfully. So these two digits have values. The error occurred on this line here. And so the value of digit 1 doesn't get updated, and this statement here therefore never executes. So what we get is the user input. The user's input is assigned to these two variables, but not these two. Okay, so we get 0, 1, and then 0, 0. How could we fix that up? Well, what we could do is, there's a couple of things. We could only display output inside this catch block here. Okay, so there's basically no output if there's an error. Well, sorry, let me say that again. We could only display the output here. So there's only, the output's only displayed if there's no errors. And if there is an error, then this message box appears and there's no output. Or we could use a Boolean flag that indicates that the input was passed okay. So I did that in one of the previous examples. So the flag was set to true inside the try, and then the output was only displayed if the input was valid. So let's do that. We need to create a variable type bool, a Boolean, and we'll give it just the name OK. So this is going to be a flag. We assume that the input is not okay, so we're going to assume the user has typed in something wrong, and so we go OK equals true. So OK only ever becomes true if the input is true. Now at this point, the way I've done this is I'm going to have to use an if statement in conjunction with the OK variable. In the practical test, I believe you don't need to use if statements, but I'm just using it in this example. So maybe I'll show you shortly how you can do this without using an if statement. Okay. So we say if OK equals true, then yeah, so this is basically saying if the input was okay, then we display the output. Okay, let's run that. Press 1 and 1. And with valid input it works fine. When there's an error, we just get an invitation to enter valid bits in the text boxes. And you see this, the output hasn't changed, it's the same as before. Let's do this without an if statement. The way to do this without an if statement might be to restructure our program. So what we'd do is we'd get the input inside the try catch as it is here, and then we'd display the output inside the try catch. So basically we'd move our whole program inside the try and the catch. Which, yeah, we can do that. Let's just do that here. So that this will become, well, let me just copy this across. And we'll move this up to here. And we'll move the output up to here. That needs to come down. We need to put the comment here. So the disadvantage of this approach is that any error is going to be caught by the try, and so we're just going to get that message box showing please enter a valid number of bits. Okay, we don't need the OK boolean anymore. So basically the whole thing is inside the try catch. If there's an error, we're going to get an error message and no output. Let's test that again, because every time we change our program we're going to test it. Oh, there's build errors. I better fix those. Name OK does not exist. Oh, that makes sense because I left it there. Delete that. Let's try again. Okay, that seems to work. That seems to work. Let's put in a mistake. Now we get the error message. Okay, and there's no update to the text box. That's what we wanted. Okay, the last bit. Okay, so we've got the input working. We've got some temporary output working, but that's not the final output because we actually need to work out what that binary digit is. So let's add another integer, which is going to be the decimal. Okay, the conversion of the binary number to the decimal. So that's going to equal 0 for a start. So we declare that, and we need to eventually output it. So let's go output equals output plus. Now I'm going to use /n for a new line. Since we've got a multi-line text box, so we can make use of multiple lines. /n will give us a new line, and what we're going to do is add that decimal value. Okay, I can add a bit of an exclamation if I like. So let's say the decimal value of this is, okay, dec.toString will convert that integer dec, which is an integer, into a string. Okay, let's check that. If I click convert, well, that's a pretty messy output. We can see that the new line hasn't actually happened, which is interesting. I can fix that. I think it's let's go, is there a new line? No. Let's go /r/n and try that. I could have had the new line character wrong. Yes, I did. So a new line in C# is /r/n. Okay, if you want a new line in a multi-line text box. So you need to remember that. So let's do some tests. We can see that it seems to work. Whoops. We get decimal value of, well, that's pretty stupid. This it doesn't grammatically make sense. So we'll have to change that. But yeah, we get dec converted to a string, and we haven't actually given dec a value yet. So let's fix that small mistake there. And let's now, yeah, so that's basically the input done, that's the output done. We haven't used an if statement, but I've shown you how you could use an if statement to do this as well. Let's now do the last step, which is the processing. So do the actual conversion. Right, so how do we do that? Let's go back to what we did here. Essentially, it's just a multiplication. So if we take any 4-digit binary number, we're going to multiply them by powers of 2. So let's do that again as a refresher. Well, let's just say, for example, we've got 4 1s. I'll copy that. We're going to be doing 1 times 2 to the 3 plus 1 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0, which is equal to 1 times 8 plus 1 times 4 plus 1 times 2 plus 1 times 1, because 2 to the power of 0 is 1. Okay, so we basically, all we need to do is we need to use these numbers here, 8, 4, 2 and 1, and multiply them by the binary digits and sum it up. So let's do that. The C equals, we'll do the first one, that's going to be digit 3 times 8, so that's the first power of 2. Now we need to add to that the product of digit 2 and 4. Okay, there it is. And I'll just copy that a couple of times. We're going to be doing the same for digit 2 and digit 1, except that the powers of 2 are going to be different. Okay, so hopefully if you followed along, you'll be able to see that this program should give the correct output, the correct conversion of a 4-digit binary number into a decimal equivalent. Let's run the program, make sure it works. Try with all 4 zeros first. Yep, it seems to give the right result. Set a 1 to here. We get 2. Is that the correct answer? Well, this should correspond to 2 to the 0, which is 1. This should correspond to 2 to the 2, which is 4. This should correspond to 2 to the 3, which is 8. So our answer is actually wrong. So we need to go back and do some debugging here. So we've made a mistake somewhere. Where have we made the mistake? Well, I can actually see that we've labeled the text boxes wrong. So we're going to fix that first. Then we're going to look and find out why we've made this mistake. Let's just go and fix that. It's not a good sign. There's always lots of scope to make mistakes in programming, but we can always fix them. Now, we've called that text box digit 0. There's the names there. There's text box digit 1. So let's try and figure out why we've gone wrong. Okay. We set the 4 variables to 0. That's correct. We parse them all into the right variables. That's correct. But when we look at our calculation, we can see something's wrong here. So we've got digit 3 occurring twice. So this is a mistake. I made a mistake here. This should have actually have been digit 2. This should have been digit 1, and this should have been digit 0. So that's completely my fault. I typed in the code wrong. So let's change that. And hopefully this time the program will work. Do some tests. We need to do extensive tests. That looks better. So 4, let's set this to 1. We get 6, that looks much better. Let's set that to 1, we get 14. That should be 8 plus 4, which is 12, plus 2 is 14, that's correct. This should be 15 because we're adding 1. Let's turn that off. That's 13, we removed a 2. That should be 8 plus 1, 9, that's correct. This should be 1, and we're back to 0. And if we type something or some non-number, we get an error. Okay, so that's about all I'm going to do for this video. We could go on and do even more checking of the inputs, because if you've been following along, you would have probably realized that we can type in valid integers that are not bits. So I could type in that and I'll get an output, so the program still works, but it gives does some other different calculation, which is not converting a binary number. We could fix that, but that would involve using some if statements, because the inputs here, the 8 and the 4, are valid integers, so parsing won't detect that these are wrong inputs. We need to use if statements. So maybe I will upload another video later on where we'll fix that. Okay, so I'm going to stop the recording now, and hopefully you found this useful and it'll help for your upcoming practical test. See you later for now.